Hello, I'm glad you're back. This is Project 4L60E, Part 2, Lesson 5. Let's assemble the input housing. After cleaning the input housing and shaft, check them for any damage. First of all, look closely inside the drum for cracks in the center. Inspect this area very carefully, especially if the forward clutch in your transmission was ruined. Cracked housings allow fluid to leak past the inner seal of the forward clutch piston in this area, causing it to fail. You should also check the input shaft. Make sure the journals here and here are not worn badly. There should only be the slightest witness marks where the shaft turns inside the bushings in the pump. If you can feel a step from wear on either journal, the shaft should be replaced. The 4 Teflon sealing rings should turn freely. Leave them as they are for now. The shaft in this transmission is the 300mm style, first introduced in 1998, and has a groove for the converter clutch behind the turbine splines. If you are working on an earlier 1993 through 1999 transmission with a 298mm style shaft, the converter clutch O-ring is located in front of the splines on a journal like this. Make sure the journal with the ring groove is round with no indication of wear. If chafing has rubbed the flat side here, the shaft should be replaced. You should always play the part of detective when solving transmission problems. Simply replacing the burned up 3/4 clutch pack in this transmission with new frictions and steels is not a thorough repair. Find out why the clutch failed. The reason in this case is a deterioration of the 3/4 piston. Years of exposure to heat cycles cause the bonded lip seals to crystallize, shrink, and eventually lose their ability to seal. The result is hydraulic leakage, clutch slippage, extreme heat, and damage. It should fit snug on the forward housing to seal. Notice how it falls off. This piston was leaking badly. This is the #1 reason why GM vehicles such as Chevrolet trucks, Tahoes, and Camaros lose third gear. There are 3 bonded seal pistons in this drum: the 3/4 piston, an overrun piston, and a forward clutch piston. Always replace all 3. Discard these now. Let's get a few new parts. Locate the input drum sub-kit from the overhaul package. It will have the inner shaft seal, the O-ring for the drum, an extra output shaft snap ring in case you lose the original one, and 6 lip seals. These seals fit the aluminum pistons found in the 1993 model. Set the kit on the bench. Get the new overrun, forward, and 3/4 pistons. Begin assembly by installing the O-ring in the drum. Get it from the sub-kit. Place it in its groove in the drum. Lubricate the outer 3/4 piston bore and all of the center area. Get the new 3/4 piston. Test fit it on the forward housing. It should fit tightly like this for a good seal. Lubricate both lip seals on the piston and install it in its bore. Set the 3/4 apply ring like so. Inspect the 3/4 piston return spring cage. If any of the springs are broken, replace the cage. Set it on the apply ring. Get the forward housing. Make sure a check ball is in its recess here. Check the inner bore. It should be free of any gouging from wear. Check these surfaces too. They should be straight and smooth. Lubricate the forward clutch piston. Place it in the housing like this and set it down. Use a feeler gauge blade to work the lip into the bore. Work slowly and put slight downward pressure on the piston. There is a chamfer to help ease the seal in, but be careful not to cut the seal. It takes patience, but it will finally go in. The fit will be very snug. Lubricate the housing where it seals to the 3/4 piston. And inside where it seals against the O-ring in the drum. Set them on the apply ring and spring cage. Align the wide tabs on the forward piston with the apply ring fingers. Pick this assembly up by the ring and set it in the input drum. Index the fingers with the wide space here. Spread your fingers evenly on the forward piston and push down. The short lip of the inner piston seal and the chamfer on the drum eliminate the need for any other installation tools. Installed correctly, the piston will be about 1/8 of an inch below the chamfered edge. Get the overrun piston. Lubricate the inner and outer lip seals. Place it in the assembly and twist it slightly as you push down. When fully seated, the edge of the overrun piston is almost flush with the forward piston. Inspect the overrun return spring cage. Check to make sure the springs are straight and perpendicular to the cage ends and not twisted or broken. Place it in the drum. Set the snap ring like so. Get the homemade spring compressor. As we did in disassembly, put the 3/4 snap ring in its groove and use the tool to compress the cage. Install the snap ring. Remove the tool. Get the 2 overrun friction plates and 2 overrun steels. They're the smallest diameter plates in the kit. Pre-soak the friction plates. Installation of the overrun clutch begins with a flat steel. Index it with the drum as you see here. Place a friction plate in next. Put the second flat steel in. Place the second friction in. The next step is to put a new shaft seal here. Get the seal. Apply some Transgel and install it here. Get the thrust bearing we set in the sprag assembly. Apply transmission fluid and check to make sure it turns smoothly. Install it with the smaller diameter race down against the end of the drum. The sun gear and forward sprag assembly goes in next, but we need to disassemble and inspect it first. Set it with the sun gear down. Make sure you're wearing safety glasses and use a screwdriver to remove this snap ring. Set this hub aside. push the inner race and sprag out of the outer race. Check both races for damage such as pitting or gouging. They should be perfectly smooth. Let's check the sun gear for bushing wear. Place the gear temporarily into the front planetary gear set and feel for excessive side play. There is little play here, but if you have more than 10 thousandths, use a 1-inch socket and hammer to easily separate the sun gear from the sprag race. Get the new bushings from the kit and replace them. The gear snaps back on with light pressure. Inspect the sprag elements. Look closely at each one. They should have a rounded face with no flat areas from wear. They should also remain in the cage as you handle it. If you find any of the individual parts of this one-way clutch damaged, I recommend replacing the entire assembly. Even though individual parts are available, very subtle changes and compatibility issues of almost identical looking parts over the years can make repairs to this assembly confusing. Our parts are fine, so let's put it back together. Begin by placing one of the brass washers on the inner race with the flat side down. Then, holding the outer race in your left hand with the wide surface facing you, put the other washer in flat side down. Like a roller clutch, the sprag elements can be installed incorrectly backwards. Since I find it hard to determine which way is correct by looking at it, I randomly put the sprag in the clutch and then check for proper rotation. Lubricate the sprag with fluid. And place it in the outer race about halfway. Roll the inner race into it. Set it down and install the hub and snap ring. To test it, hold the hub in your left hand like so. The outer race should turn freely in the clockwise direction. It should lock in the counterclockwise direction. If it works backwards, take it apart and flip the sprag over and reassemble it. Set the assembly in the drum. Rotate it back and forth so that it splines with the two overdrive frictions and seats onto the thrust bearing. Get the forward clutch apply plate and place it in the drum. Notice how these 5 tabs will sit on top of the 5 rectangular fingers from the forward piston. The wavy steel goes in next. Look at it sideways. The deliberate waviness acts as a cushion for the forward clutch when placing the transmission into drive. Get the 5 new forward friction plates and the 5 new steel plates. Dip the forward frictions in transmission fluid. Install a new flat steel on top of the wavy plate. Install a friction plate. Install a steel. Place a friction plate in. Continue this stack up until all 5 steels and all 5 frictions are in the drum. A friction plate should be last. Get the forward clutch end plate and place it in. Install the snap ring. Note that this ring has a smaller diameter than the 3/4 clutch snap ring. Use a feeler gauge set to measure the end plate of this clutch pack. It should be between 30 and 65 thousandths of an inch. If the clearance is outside of this range, there are 6 selective end plates of different thicknesses available to adjust it. Installing the 3/4 clutch begins with a close look at the snap ring, end plate, apply plate, and the load release springs. Although they appear to be ruined from heat which destroyed the frictions and steels, let's take a second look after being cleaned with solvent. I've cleaned up the bench by removing all of the old clutch plates, drum seal, and O-ring. I have also cleaned the 3/4 clutch parts. Even though it looks as if I haven't done anything at all to them, they not only have been cleaned, but are also in perfect shape and reusable. Here's why. They're simply stained black. I used a straight edge to find out, more importantly, that both the end plate and apply plate are still flat. The condition of the plate surfaces where they contact a friction are good too. They're smooth and free of any evidence of metal to metal gouging. If yours are not flat and have a dished or bowed in condition, they must be replaced with new flat ones. Get the new 3/4 friction and steel plates. This master kit comes with 6 frictions and 5 steels. Pre-soak the 6 friction plates. The majority of 4L60E transmissions have 6 friction plates in the 3/4 clutch. However, there are variations in the number, thickness, and stacking arrangement of the friction and steel plates depending on year and model. Let's assemble our 2004 clutch, which represents the most common stack-up, and discuss the variations after we finish the input drum assembly. Start by installing the apply plate. Notice how the 5 tangs here sit on the apply ring. Place a new friction plate in. Place a new steel in. The small tabs with the wide space between them go in the wide space in the drum. Put a friction plate in. Install all of the 6 frictions and 5 steels. The last plate should be a friction. Get the 5 load-release spring assemblies. The springs should protrude from their housings about 1/8 of an inch. If yours have receded down from heat damage, they should be replaced with new ones. Install them like so. Install the end plate. And the snap ring. Use a feeler gauge set to check the end play. It must be between 60 and 85 thousandths. I have 3 feeler gauge blades that total 66 thousandths. They fit a little snug, but we're in the 60 to 85 thousandths range. It is critically important that your measurement fall into this range. There are selective end plates of various thicknesses to adjust the end play if necessary. Now that the input housing is completely assembled, we can check it using compressed air. Get the rubber tip blowgun and set the pressure to about 40 psi. To check the 3/4 clutch action and the piston which applies it for leaks, turn the housing over and apply air pressure to the hole in the shaft closest to the drum. Hold a finger over this air bleed hole and place the rubber tip in this hole and apply air. Notice it does not leak at all. Remember that this is the piston which did not seal tightly. The old piston would have leaked air with a hissing sound. In fact, the piston would have leaked so badly I doubt it would even move to apply the clutch at all. Watch how the clutch applies. Apply air to the middle hole and test the forward clutch. You can see the clutch apply here. The hole furthest from the drum is for the overrun clutch. To test it, you must cover up the middle hole. It's also sealing well. To complete input housing assembly, replace the selective thrust washer and thrust bearing. Get the washer and notice the 2-digit number on one side. This number is not a statement of thickness in thousandths. It's a reference code for a thickness range. For example, the numerals 68 on this one refer to a thickness range from 80 to 84 thousandths. This washer is used to adjust pump to input housing end plate, and there are 7 different thickness ranges that I am aware of. Here's a list of the washers with codes from 67 to 73. It will sit on the drum with the numbers down. Look closely at the other side and notice the ground surface and sharp edges. It supports the larger race of the thrust bearing. Set it in its recess. Get the bearing. Put transmission fluid on it. Make sure it turns smoothly without any chattering from pitting. Place the bearing on the washer like so. Earlier in this lesson, I mentioned that there are several variations in the stacking arrangement of the 3/4 clutch. There are 4 that I am aware of in North America. The most common is found in the 1994 and up 4L60E. It has 6 80 thousandths thick frictions and 5 106 thousandths of an inch thick steels. The second arrangement is found only in 1993 models. It uses the same 6 80 thousandths of an inch thick frictions, but has 5 thinner 76 thousandths thick steels. The third is found in the 4L60E paired to the 2.2 liter engine. It has only 5 80 thousandths thick frictions plate and 6 106 thousandths of an inch thick steels. It's unusual because 2 steels are stacked back to back in the middle of the clutch. The fourth arrangement is found in the 4L65E and 4L70E behind the 6 liter engine. It uses 7 65 thousandths thick frictions and 6 97 thousandths thick steels for higher torque levels. Regardless of how the 3/4 clutch pack is stacked up, it should always have an end play between 60 thousandths and 85 thousandths. This concludes Lesson 5. We'll move on to the reverse input drum and pump in Lesson 6.